hopefully you're pros at finding the domain and doing some basic sketching with those vertical and horizontal asymptotes from yesterday. Today we are going to get into it and determine how to find those vertical and horizontal asymptotes from a function. Okay, and so first up we're going to do vertical asymptotes. Here's just kind of a list of everything we're going to be doing. Okay, a couple highlights on it. First off, we're going to be factoring both the numerator and the denominator. Now you're going to be asking me, why do I have to factor both of them? You're going to see we're just going to be using one or the other. You'll see why before the end of the video. Okay. We've already done the restrictions on the domain of the function. We'll talk about that a little bit. But right here, if I can reduce, I definitely want to. If I see something, a common factor on top and bottom, numerator and denominator, let's get rid of that dude. Okay. So anything that makes the denominator equal to 0, all right, that is going to be my vertical isotopes. Okay. Anything that, so any of the other restrictions that I have, so anything from number 2 up here that has left the equation, I'm going to have to come back and get for a removable discontinuity. So a lot of stuff going on with this. I think you're going to see it's very similar to what you did in your homework yesterday. Okay? And I apologize, I'm having a little bit of trouble with my computer today, and so I'm going to have to write this equation in there. I went to edit it this morning, and it wouldn't let me put my new one in. So we're going to do g of x equals 6x squared plus x minus 1 over 3x squared minus 5x minus 2. Okay, so step 1, get the numerator and the denominator factored. So I'm going to factor the top. Looks like I could probably split that apart, 3x and 2x, just using an old guess and check on this. Maybe like a plus 1 here and then a minus 1 there. Check that. I think that does work. Hopefully you're getting better at that whole guess and check thing by now. So 3x and x, that's the best way I can split up 3x squared. I think if I put the, let's see, I'm trying to get a negative 5. So if I put the minus 2 over here and the plus 1 there, negative 6x, yeah, that works. So for the vertical isotopes, what I'm doing, it's going to look very familiar, is I'm just taking whatever makes this bottom down here equal to 0 and solving for x. So I get 3x equals negative 1. X would be negative 1/3. So I would have that imaginary vertical line at negative 1/3 eventually whenever I'm wanting to graph this. Okay. On the other one, I'm adding 2 to both sides. I get x equals 2. Hey, you might be saying, why in the world did you factor that bottom out, or the top? Well, there is a reason. Just hold tight with that. Okay. And so these two down here would be my answers. Okay. And you're going to hear me refer to these as VAs, okay, or VAs. Vertical asymptotes is kind of tricky to say, so I just call it VAs. That's a lot easier for me. So what's going to happen is if the vertical asymptote decides to match up with part of my numerator, a factor in my numerator, it's going to give me something called a removable discontinuity. A removable discontinuity, what it looks like is that I just took a hole punch and just punched out part of my graph and just took it out completely. Okay? And so let's see how we're going to get our hands on that. So we're back to having to factor this. Okay. It shouldn't be a problem. I'm going to go ahead and get through and factor this. If you need to pause it, if you want to work on your factoring, please do so. So I'm thinking if I put a minus 2 here and a minus 3 there, that matches up. I like the bottom. It's the difference of 2 squares, x plus 2, x minus 2. So I've been asking my classes today, go ahead and tell me your vertical isotopes. And they're like, oh, well, Mr. Lovely, it's positive 2 and negative 2. No, because something weird's happening right here. Look at this. This matches. Kind of. I know if I have a factor on top and bottom, I can reduce my equation down to just 2x minus 3 over x plus 2. And so if that happens, I definitely want to do that whenever I'm looking for my vertical asymptote. So I'm not going to work that out, but my vertical asymptote would be x equals -2. So what happens whenever we get this common factor? Because remember, we do have a domain restriction on this. We know that x cannot equal -2 and x cannot equal +2. So I see where at this -2, I have a vertical asymptote. But what in the world's going on at 2? Well, that's where that removable discontinuity comes in. There's going to be a hole right here. Okay? And so what I'm going to do is I want to take this removable discontinuity. I'm going to find out exactly where it is. Let's see, removable discontinuity. Okay, so the removable discontinuity is going to be, well, it's going to be at 2 something. Okay, and to find out what it is going to be, I'm going to take that 2 and I'm going to plug it back in for these x's on my reduced equation. I know that seems really weird, and I might explain why that happens in just a minute. But if I plug in a 2 in for the top, that gives me a simple 1. And if I plug in a 2 in the bottom, 2 plus 2, last I checked was 4. So the removable discontinuity, where I'm going to hole punch my graph at, the branch, is at the point 2, +1/4. Okay? I know that seems weird, just a little bit of as to why this works. What happens is this reduced equation right here looks very similar to my original equation, or even if you want to draw an arrow to this original equation. So much so that they look exactly the same at every single point on the graph except for one point. And yeah, you guessed it, that one point is at the point 2, 1/4. What happens is this blue box right here, it does not have a hole at 2, 1/4. I'm originally trying to graph this g of x up front. That does have a hole right there. So they're very similar graphs, except for this g of x up front, he has a hole at 2, 1/4. While this 2x minus 3 over x plus 2, he does not have a hole. So we can use that to help me graph. More will come on that with video 3. So that's a rundown on vertical asymptotes. I know I haven't given you one to work. I plan on doing that before you get out of here. But the horizontal, horizontal asymptotes now. Rational function can be determined by the degree. Thrown this word down a couple times today. Make sure you know that degree is the highest power that you see in a polynomial. So if it's in descending order, it's that very first exponent that you see. And what I like to do on this is I like to turn it into a competition. Degree of the numerator is less than degree of the denominator. Well, in my eyes, that means that the denominator won. The denominator has a bigger degree, okay? And I will actually come down here and say, hey, guess what? The bottom wins. When the bottom wins, he gets to decide what he wants to do with the horizontal asymptote. And so anytime the bottom wins, he decides that he wants to put a vertical asymptote at y equals 0. There's actually a lot more to it than that, but for what we need to know in this class, that will get us by and help us find where it goes. If you're interested in more of that, please take calculus with me. It's a fun class, and we'll figure out why that happens. Now, the next one, it says the numerator wins. It's greater than the degree of the denominator. So I just say top wins. And if the top wins, the numerator gets to decide where to put the horizontal asymptote. And he says, you know what? I'm lazy. I don't want to have no horizontal asymptote. Not like that's how that's on 2 different lines, but no horizontal asymptote. And finally, what happens a lot on this is we get them to be equal. All right, it's a tie. Kind of like a bad soccer match on TV. You sit there and watch it for however long it is, and they end it in a stinking tie. All right. And so when that happens, what we're going to do is my horizontal asymptote is going to be a ratio of leading coefficients. Okay, leading coefficients is that number in front of my polynomial, all right, or the number that goes with the degree of my function, the big number in front. Okay, so let's try some. Let's just try to find some horizontal asymptotes. careful on this first one right here. On f of x, if that is a 1 right there, that means that it's a constant term. It's like 1 times x to the 0, except for they got lazy and didn't put x to the 0 because x to the 0 is 1. So the degree of this top right here is 1, while the degree of the bottom is 1. I'm sorry, the degree of the top is 0, the degree of the bottom is 1. That means the bottom wins. And remember, anytime the bottom wins, he wants the horizontal isotope to not move. He just wants it to stay there on the x-axis, y equals 0, and be done with it. Okay, so not a lot of math to be done here, just being able to recognize some terms and figure out what's going on. All right, part B right here. Oh, we tied. They're both being raised to the second power, the tie. So here's where that weird ratio of leading coefficients is going to come in. Oops, I need to switch colors. Ratio of leading coefficients. Well, the leading coefficient, the number that's in front of the degree right here is 6. And ratio, I'm just going to put a division bar, so it's 6 to whatever the leading coefficient is on bottom, 3. Well, 6 divided by 3 is 2, and that is where it would land. So if it's a tie, you've got to do a little bit of math, that little bit of division. And on this problem, the horizontal isotope would move up 2 units and then be at positive 2. Oh, I like C. C, now careful, I put the x cubed back here. So the top still wins, okay, even though the x cube's back here. If you need to rewrite this in order, please do so. Now I definitely see the top wins. Degree of the top is 3, degree of the bottom is 1, top wins. There is no horizontal isotope, okay? That doesn't happen a whole lot when we start graphing. It might happen some. You try to find this one. I'm going to try to trip you up a little bit, put it in factored form, but I think you can still get it. So go ahead and hit pause, and then I'll have the answer up. I mean, the vertical isotopes on that were easy, weren't they? That probably means that horizontal might have to require a little bit of work. Now, I didn't have to go ahead and multiply everything out. Remember, I just need my leading terms right here. And sure enough, I got a tie, 4 over 1, gives me 4.